Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. Welcome, Warren.
Gil, thanks for inviting me on your podcast.
My guest today is Professor Warren Powell, who taught at Princeton University for almost 40 years, where he was drawn to the opportunity of bringing advanced analytics to the trucking industry, which would introduce him to the challenge of making high-dimensional decisions, such as assigning drivers to loads under uncertainty. This problem guided him a lifetime of research in stochastic optimization using approximate dynamic programming. His research produced over 250 papers and 2 books with the help of 60 graduate students and postdocs, supported by $50 million in research funding. Thanks for doing this, Warren.
Well, I'm looking forward to this conversation. I enjoyed seeing your background in decisions. And I would say that that's the word that eventually ended up defining what I do, because I moved from transportation into a variety of different areas, energy, health, laboratory sciences, e-commerce. And I found that what really pulled it all together was understanding decisions.
Right. Yeah. The situation that we are in today, the major shock that happened to the economy and the disruption of the supply chain globally. I wanted to get your perspective on, what have we learned from this? Did we manage it properly? Could we have done things better? And more importantly, if we were to have a similar shock in the future, what would you say we should really think about, focus on, and maybe do things differently in the future?
So I'll be honest, I'd love to come back to that future question as we make some progress through this, because the COVID pandemic is a fabulous example. Some years ago, when Hurricane Katrina went through, I used that as an exercise in understanding the flow of decisions and information. And so I started, when COVID-19 hit, I started doing some of the same exercises of downloading all kinds of information and sort of just listening and trying to understand what was happening. Yeah. But given my career, I couldn't help keep coming back to, if we want to do a better job, you have to make better decisions. And so I like going through an exercise of saying, what are the decisions? But with COVID, you especially have to start by asking yourself, who are the decision makers? And we've seen this unfolding in the news with the fights between the state. I mean, there's many decision makers, but the fights between the state governments and the federal government has been what's really in the headlines. Right. And I think if there's a lesson to be learned, gosh, we can't have that kind of fight in the future.
Yeah, that's interesting. So, in a corporate structure where there is a more defined hierarchy, I guess there is less confusion about who makes the decisions. It may not be absolutely true in very complex and networked organizations, but more hierarchical organizations, there is less decision complexity, I would imagine. But in this situation here in COVID, like you say, the federal government, the state government, the local decision makers, the hospitals, the manufacturers, and it's not just the decisions that they make, but also the coordination of those decisions, right? Especially from a transportation, logistics, supply chain perspective.
Well, I think the biggest complaint, and of course I've enjoyed watching Andrew Cuomo's sessions, is the issue of who should be purchasing supplies, because the federal government sort of said, well, it's up to you states to get your own supplies. So now you have 50 states all competing against each other and competing against the federal government, because FEMA would come in and says, oh, no, we want those. Either we'll bid higher, or in some cases, they had already had contracts in place where they could come in and leverage supplies, the PPEs and that type of thing. And that's been really frustrating to the states.
Right, right. How would you, again, going back to the future question here, let's say we encounter something similar in the future. What would be, from a decision clarity perspective, how would you organize that? What have you learned from the past here?
Well, if we could stay close to the context of a pandemic, so the first thing that we know is we're going to need a lot of supplies. It makes no sense to have 50 states bidding against each other. I mean, people were just, the governors were just pulling their hair out. So the number one thing is you have to take specific decisions like who's acquiring supplies and figure out who's going to do that. And of course, that just has to be done by the federal government. So that's certainly one something that needs to be settled before the next pandemic, is to say, okay, who's making what decisions? Another area where there was debate was we saw our president saying, okay, I'm going to demand that the states open up. And clearly the states were saying, sorry, that's a state decision. I think that's just a matter of clarity, but those types of debates should not be happening.
Yeah, so the fact that we didn't have clarity on who is making what decisions when creates a level of uncertainty in the entire system. And so again, going back to how do we make this better? How do we optimize this? What can we bring from your understanding of managing under uncertainty, making decisions under uncertainty that we could bring to the policy arena in the future?
Well, what I would do is, first of all, sit down and make a list, as long a list as needed, of what are the key decisions that are being made, and then figure out who's going to make those decisions. I mean, that just has to be unambiguous. I mean, it's sort of like a 6-year-old arguing with his parents over, who's going to decide what he wears to school, okay? That just shouldn't be happening in a pandemic with a country. Basic decisions like, who's going to acquire supplies, that just should be unambiguous. It should be clear. Oh, you go to the federal government. They'll order the supplies, they'll distribute and coordinate among the states. I mean, I was ready to call Cuomo and say, look, Andrew, you're a clear leader here. Get the 50 states on the phone, make your own committee.
Right.
I mean, there's no antitrust here. And I'm not really quite sure why they didn't do that on their own when it was clear that the White House wasn't providing the guidance.
Yeah. But even downstream, Warren, even if, let's say, we had clarity at the decision layers, we would still have very high levels of uncertainty downstream, right? So there were a lot of modeling happening in terms of how the incidence rates are going to increase, how the hospital capacity is going to be claimed. There's a lot of modeling, but I look at some of these models, and so such wide uncertainty bands around the predictions, they almost appeared useless to me from a decision and implementation perspective.
Yes, I have to admit, I mean, I'm a modeler. I do a lot of work with modeling, but I haven't done modeling with this scale of uncertainty. So I was looking, like I'm sure you were as well, at the IHME model. and they would have these nice point estimates. And then you would
Yeah.
see the uncertainty bands. And I mean, nobody was paying attention to the uncertainty bands, but they were all over the place. I mean, they were
Right.
so wide to be useless. But then the news stations would report the point forecast as if that's the forecast. And that's something that
Right.
I see happening over and over again in my own work. And I caution companies I work with. I says, look, this word forecast, everybody thinks a forecast is a point forecast. So IHME, to their credit, they gave these uncertainty bands, but the uncertainty bands were so wide to make it all but useless. So
Right.
now you have Andrew Cuomo sitting on the phone saying we need 30,000 ventilators. The federal government was pushing back, going, well, sorry, we just don't have that. And Cuomo didn't end up needing 30,000 ventilators, but he sat there and says, well, but I might. There's enough
Yeah.
uncertainty. But then he
Yeah.
was making requests for that were just unachievable. And I'm not pointing fingers at anybody, but really there is this much uncertainty. I mean, look at the IHME forecast that I think started in the 100,000s and suddenly dropped to, I think, 74 or 60. I think at one point it was down to 60.
Yeah.
And then it was up to, last I saw, it was up over 130, 140, somewhere in there. I mean, that's swinging all over the place.
Right. Right.
And it hints at the types of uncertainties. So, I mean, first of all, you have all the uncertainties of the disease. What's the R factor and that type of thing. But then you have the social distancing and the extent to which different communities will follow regulations. And
Yeah.
and that was the IHME people. They kept focusing on that because they were saying, well, we just don't know what people are going to do.
Right. Right. Yeah. The uncertainty bands is an interesting thing. So, one of the things I talk to my clients about, and what I have written about is, this idea of scenario analysis, right, which, as you know, is very prevalent in corporate decision making and analytics. And everybody does a most likely scenario, an optimistic scenario, a pessimistic scenario. It all sounds intuitive sense, but if you have scenarios that span a very big uncertainty band, it doesn't really have a lot of utility for decisions. And so from a modeling perspective, how would you handle that? People do forecasting, people do predictions, but then say, well, if you look at optimistically or pessimistically, it's here and there. From a decision maker's perspective, how should they internalize such information?
It's the thing is, if as a modeler, if I'm going to give these wide uncertainty bands, I think they would call that, a cover my ass uncertainty band. And I say, well,
Right.
it was within the uncertainty band, but decision makers do need, some level of precision, because otherwise then the model isn't actually doing anything. So
Yeah.
it's very hard. One of the companies I've worked with was sitting in my lab asking about uncertainties and how to identify and quantify. And I says, look, get a couple of 6-packs of beer and a whiteboard and brainstorm, because I find like if you take COVID, simply asking what are the decisions is quite an exercise. Okay, it's not easy to simply list what are the decisions, but now turn around and say what are the uncertainties.
Yeah.
And I love Donald Rumsfeld's phrase of the unknown unknowns, because you've got the known unknowns, for example, how people respond to social distancing. I don't know what they're going to do, but at least I know that it's a quantity. And then you have the unknown unknowns. And some of these unknown unknowns have had to do with, less so in the United States, but in other countries, these pockets of immigrants. That people just didn't pay attention to. I think Singapore, which is, talk about a country that is as tightly controlled and amenable to controls. And so they seem to have everything locked down, completely overlooked these immigrants. And so you have these pockets where events are happening that people just didn't even think of. And that always has to be out there, the unknown unknowns. The known unknowns in something like a pandemic, the social distancing, for example, is a real question mark. how long people will stay locked down. I'm starting to conclude that, you know what, this disease is here to stay until we get a vaccine. We can slow it, we can't stop it, and it's going to work its way through the population because the simple fact is we can't all sit and live in our own homes.
Right, right. Yeah. And, it's interesting that even in the US, one of the unknowns and one of the assumptions, I think, in the model that wasn't really there was initial conditions. And so, it is now becoming clearer that the disease has been going on in the tri-state area probably from November, December timeframe, right? So when the disease started and how prevalent it was in the population when they started the modeling process, those initial conditions affect the affect the outcomes remarkably, right?
Oh,
And I didn't.
yeah,
Yeah, go ahead.
so this has been the big problem with this virus because, first of all, it's in the wintertime. The flu is already in the population. We have flus every season, and it's just something we've, as a human race, they've learned to live with. And some people get the flu more seriously. And so along comes this new flu that, first of all, you have a lot of people with no symptoms, so we don't even know that they have symptoms. And then you have people
Yeah,
with varying degrees of symptoms, some very, very serious. But when you're when you realize that nobody's, at best, I mean, nobody has any experience with this. I mean, we haven't had this type of a flu since 1918. And so when if the occasional case starts popping up, everybody just ignores it. It's the flu. Oh boy, that person got it really bad. Well, you know what?
yeah, right.
Pneumonia is out there. People get pneumonia. People die of pneumonia. So I
Yeah,
love, we're going to do an awful lot of Monday night quarterbacking as this comes to a close. We're going to have to try to remind ourselves of the context and what we knew and our past experiences when we think back to the January and the February where everybody starts pointing fingers and going, look, let's face it, nobody had it back then. I mean, I think
yeah,
late February, maybe almost early March, I was probably still being slightly dismissive until I got the email from Princeton. And it was
mm,
clear that they were consulting the top authorities that pretty much said, get out of here, go home, no more
right.
meetings.
Yeah,
And that was before it was on my radar screen. But as soon as I got that email, I'm like, okay, we're shutting down. But
yeah,
but
yeah.
the clearly the experts were, I mean, I was pretty well read. I was looking around, I was listening. It wasn't on my radar screen.
Yeah, it's because it's such an unexpected and unusual thing. And like you say, the sort of the connection between, not connection, but the idea that it's happening in conjunction with common flu, which in the US, I think something like 40,000 people die every year. Similar symptoms. Sometimes it's really difficult to disconnect the two. And so again, there were a lot of assumptions going into this modeling, as well as our own expectations that were not true, right? We didn't really know the incidence rate and the spread that well. Now, I was looking at something else, Warren. So now, the antibody tests that are beginning to become available more widely to see if you already had the disease, and it has sensitivity and specificity in the range of 90-95%, which sounds like a really big number. But what that means is that if you take a test and you get a positive test, you still have only about a 50% confidence at the individual level that you have the antibodies, right? So it is not something that we can use to let people back into work. Do you have some thoughts on where those tests should be in terms of sensitivity and
Well, so
specificity?
I have a brother who's a practicing physician in oncology, and my daughter has a PhD in health. And I
Yeah.
reached out to both of them on this issue, and both of them came back and says, "Oh my gosh, you can't trust those serology tests." First of all, it's
Right.
not just that they're not that they're inaccurate; it's that they're testing for antibodies that can come from a number of sources. So I'm not going
Uh,
to say much more on that because I know enough to know that you really have to know what you're talking about there. But these antibody tests are I think you've already hinted, they're no panacea at all. That's I mean, the problem is you get a certain number of false positives. We're still at the point where the total number of people who appear to have been exposed are barely bumping up against double digits. Many areas they're still in single digits, which means the vast majority of people getting the tests have not had the disease, which means the vast majority of positive tests are false positives. And so that completely distorts everything. I mean, I've got this feeling that this disease is going to have to either, by being infected or a vaccine, it's going to have to run through the entire population. And it just, we can slow it down, but we can't stop it. We're all going to eventually have to get out of our homes. I mean, right now, the last I heard, and this was just a day or two ago, here in the tri-state regions, New York, New Jersey, Connecticut, that most of the people coming into hospitals right now are people who've been quarantining at home. And so we go to the grocery store, we wear our masks, we're careful, and guess what? We're still getting it. And so I think we're just going to have to be patient. But the sad fact is for those of us who have any sort of health condition or older, it's going to be a risk. One of my students got the disease. It was not bad. He got through it just fine. But as you get older or have other conditions, it's a genuine health risk that is, we're just, I think it's going to be part of society. We're just going to have to live with it.
Yeah. I want to switch back to the supply chain question again, Warren. So, one of the things that we noticed is that companies in the U.S. have obviously global supply chains. They have shifted manufacturing to low-cost countries, and it all sounds pretty good when things are all working out. The incremental cost reduction that the companies are getting fall into their economics, and everything is good. But what is not in that decision process, it appears, is these types of shocks, right? That suddenly, basically detach them from their supply chain with no redundancy built into it. So how do you think about supply chains, after the shock?
So there's no question that supply chains are over optimized. In the 1990s, these powerful optimization tools became quite popular. You put in all the costs, the transportation costs, everything, it'll pop back and say, here's your least cost solution, which was often China. And so what you've got is this creating these very fragile supply chains. What we've got to do, for many reasons, not just the pandemic. By the way, when the Fukushima disaster happened, it turned out that area was the only place that certain types of components were made for cars. I remember the last time I went to buy a car, they said, well, we can sell you the car, but we'll have to install the backup camera 6 months later because the key component came from an area near Fukushima. And so spreading out supply chains is clearly going to be on everybody's radar screen to make things more robust. Now, here's the interesting thing. So you can have a Fukushima reaction. So you can say, well, look, there can be, let's think of sort of the types of random events that can shut you down. And so a bad earthquake, maybe social unrest, things like that. Then you start thinking about a pandemic and you sort of say, okay, what is the best way to protect yourself? And, I don't want to get into politics, but we also had the other twist of having the United States that for this particular time with this particular president had targeted a particular country. So you have the issue of restrictions on a particular country just because of politics. But a pandemic, I remember years ago when the SARS virus hit and it was starting to shut down, well, certainly China because it had started there, but, as these pockets would come up, suddenly there would be, okay, we can't do something there because there's a SARS outbreak. And these viruses, they can bounce from country to country quite quickly. So this is where you may start thinking, maybe Eastern Europe and Mexico, places really far apart.
Right. Yeah, so it's a question of sort of redundancy, but it's also an optimization problem from a cost perspective, right, for companies. And you can, if you look at that, the economic uncertainty or economic risk that companies are carrying, perhaps they can cut the tail off by doing some business interruption insurance type thing. But it seems to me that the objective function they were trying to maximize before was sort of simplistic. Like you say, just plug in all the variables and outcomes, go manufacture in China and your cost goes down by 3%. And that is, from an accounting perspective, looked highly attractive. So do you think, how do you think the companies will look at this in the future?
Well, I think that there's going to be a surge of interest in companies talking to people who understand uncertainty and can have some expertise in designing the types of strategies to deal with uncertainty. It's not going to be easy. One of the challenges is supply chains. For a complex product, and let's talk about a car, an iPhone, maybe laptops, anything with some level of sophistication, you get these very rich supply chains. I did an academic research project for Pratt & Whitney and on their supply chain for jet engines. Holy smokes. We had this multi-agent simulator running, and then we'd go in and says, oh, this one supplier is going to have a week's worth of labor unrest. And then we would shut that company down for a week. The problem is, if he's not providing his parts to the next upstream, then you start getting this ripple of these upstream suppliers have to shut down what they're doing. Now that ripples in both directions, because now the people down toward the end product aren't getting what they need, and everybody upstream is also starting to shut down because they have now no longer have somebody to send their products to. And one shutdown of one vendor for, say, a few weeks in the Pratt & Whitney supply chain, and all of a sudden we had this animation going, and you would see the whole company going quiet. And then you have the problem of starting everything up again. You have to really understand how difficult these supply chains are. So and the number of strategies you have to overcome this are really limited. One is called inventory, okay? And, when I started my career, this was just when we were discovering the just-in-time inventory that had been pioneered in Japan. And everybody learned you don't want inventory because inventory creates all kinds of other problems. You can have more than one vendor supplying the same part, so you have some flex. And that has pluses and minuses. At Pratt & Whitney, they would say, look, one of the issues there is they're constantly leaning on suppliers to get product. And when a supplier knows that he's a sole source, they really bend over backwards because they know, oh my God, I don't want to shut down the whole supply chain just because of me. But if you're not the sole source, then all of a sudden you're not the only guy, and maybe I can, go do something else, or work for a competitor, or do something else. And so they actually found that having multiple sources, which can look good inside a computer model, may not work so well in practice. You can do financial hedges. The problem with financial hedges is it's just saving people money. I mean, it protects you financially. Yes, it matters. But the real world is a physical world, and the product has to move. And, that's to just say that you're going to buy an insurance contract doesn't solve the fact that you've got, when the meat production plants started to have to shut down, and then they started to have to shoot all the pigs. I mean, life in the real world is hard.
Yeah, it's. Do you think, I sometimes write about this a little bit. If you think about education, operations research, business school, education, a good part of that is really about deterministic views. So in finance, for example, project cash flows deterministically, use a discount rate to come up with net present value, and then make a decision based on that. And this has been the conventional view of how decisions are made. But when you go to the real world, you quickly find out that you don't really have any determinism in any kind of forecast or expectations. What you have set of uncertainties, and the real question is, how do you make decisions under
So,
uncertainty? Which I believe is not really taught. That I would love to get your perspective. Not really taught
yeah.
systematically in
So my career started
universities.
in
Yeah,
1982 when a large trucking company, Schneider National, that had these big deterministic models back in 1982. It's really pretty impressive. But they had hired an
yeah,
operations research guy who came in and says, Warren, it's not you know, deterministic. It's stochastic. These trucking companies, and they're calling in at the last minute and saying, hey, I have a load that needs to be moved tomorrow. And I sat there over dinner and I went, holy smokes, what a great question. I don't even know how to think about it. And I will tell you, it took me about 25 years. And then in
yeah.
2004, guess what? Schneider National came in and gave me a project. But by then, and
Mm-hmm.
most of this, like the 1980s, I just thrashed around. The 1990s, I started to sort of get it. In the early 2000s, I had my aha moment. And then since then,
Mm-hmm.
I went from having an initial eureka moment to realizing, oh, wait a minute. Now, and every year or two, I would have another aha moment, to the point that I think I finally got it. And I now know how to teach uncertainty in optimization in a way that does not need a PhD in mathematics. Okay. And that's really key, because
Yeah,
once you take deterministic optimization, which can be taught to undergrad engineers, okay, and you put uncertainty into it,
yeah.
holy smokes, academics go crazy with their crazy math. And I finally realized, first of all, here's one thing that's really odd. We're really bad at teaching how to optimize under uncertainty, but we humans do it every day. I mean, it's astonishing
Interesting.
that
Yeah,
we're
right.
actually quite good at it. And one of my favorite examples is how to get from A to B. And Google Maps, I pull it up and it gets me my shortest path. So let's say I'm traveling
Yeah,
into, I don't know, New York City, and I'm worried about congestion and delays and whatnot. The fact is, I'm probably going to live with my Google Maps path, but I also have to decide when to leave, how much buffer time to give. Now, Google Maps doesn't really help us with
mm-hmm.
that, but as a human, I sort of know, okay, I add another 15 minutes or 20 minutes. If I do the trip often enough, I'll learn that I'm either adding too much or too little. And this is how we humans learn to adapt. We're not teaching this in schools, okay? And I finally put
Right.
together, I had a grad course, but I've also put together an undergrad course where I started saying, I think I know how to teach this to undergrads. Now, so I'll toot my horn just a
Mm.
little bit to say it took me a career. It took me a career to figure out how to properly teach
Yeah,
decision making under uncertainty. But then I'm going to point out that there's still some things that I haven't mastered. One of which is, well, guess what? Nowhere in any of my models would I have thought to put in a pandemic. Okay. So the thing is,
okay.
uh, I've
Yeah,
gotten to the point where I know how to think about decisions under uncertainty. When you teach formally how to optimize, it is always deterministic. That is what's taught around the world. It's deterministic optimization. I've learned that there's a specific way to
right.
approach uncertainty, that if you have uncertainties, here's how to approach decision making, which has to do with what I call policies, or a rule for making decisions. And I was able to finally
Yeah.
identify that there's 4 fundamental classes of policies. And this was my big breakthrough from just a few years ago. And that's cool. So I'm writing
Mm-hmm.
this book, and I do have a chapter called Uncertainty. And I apologetically say, well,
Right.
it's a 30-page chapter. It should be 300 pages. I have a talk where I allocate one slide to uncertainty, because I say if I do more than one slide, I'll be acting like I know what I'm talking about. The simple fact is,
Right. Right.
we don't have a good handle. I mean, even with my whole career, and I finally stood on the top of the mountain and said, oh my gosh, it's amazing, I figured it out. And so I'm retiring from Princeton to travel around the world and give lots of lectures. Uh, Even there, there's issues that I haven't mastered, like how to design that supply chain given the unknown unknowns.
Mm-hmm.
The company I'm working with had asked for help with uncertainty, and my advice was to get a couple of six packs of beer. I mean, that's pretty weak advice.
Right. Yeah. Yeah. I think that's the point though, because there is a tendency to jump into data and make complex, often deterministic models. But what is not really done is to spend time to think about the assumptions and the uncertainties in those assumptions, and that is going to help make those decisions, a lot better. I want to go into another area of your expertise, Warren, and that is transportation. And I want to get your view on this. So, it seems like autonomous vehicles are really taking off. We are removing, I should say, the human component, and correct me if I'm wrong, reducing, I should say, the human component in transportation as vehicles get smarter. What are the implications of that in the future when you think about transportation
Well, so
systems
let's
and
be careful.
optimizing
We've
those?
got public and passenger transportation and freight transportation. To be fair to our audience, my background is in freight transportation. However, my office
Yeah,
at Princeton, I sit right next to a colleague of mine, Alan Kornhauser, who has lived his entire career. In fact, I was an undergraduate at Princeton, and Professor Kornhauser was my professor back then. And back then, his passion
yeah,
was, they called him personal rapid transit, PRT. And today
mm,
I think he's close to 75, but his passion is these driverless cars. He's lived his entire life on driverless cars, and so he's kept me very up to date with that. My reading of passenger transportation is we're still maybe 15 years away from finally getting cars to drive themselves down the road. It's going to happen. It's going to happen much more slowly. But what is starting to happen
mm,
is autonomous trucks, but not on the highway. I mean, there's some talk about autonomous trucks,
yeah,
but I'll tell you, it's pretty much limited to the idea of platooning, having 5 trucks drive really close to each other so they get some drafting. That's pretty minor.
right.
What they are starting to do is have these robotic trucks run around freight yards. It is not on the highway, but within a closed system. But this will be so. This
Mm,
equipment does exist, and people are starting to have an interest in. Okay, well, what do I tell the truck to do? But at least it's not on the highway. You don't have the public safety dimension. But this work like this is going to be the type of work that helps us develop the technology. I mean, you have Waymo and GM's Cruise division is doing quite a nice job, uh, and that are really well ahead of
yeah,
everybody else. But it's just what we humans do in driving cars. Let's just face it, the brain is an amazing thing. However, everybody sees the economics, everybody sees the potential. Let me say, I think Amazon is very, very anxious to use autonomous delivery vehicles for the final mile types of things. It's just so
yeah.
fabulously expensive. It makes the incentives too great to ignore, and the technology is too far along. You can see it, you can almost touch it, you can smell it, and you see all the potential. But gosh, is it hard? And part of the problem is, if we have,
Yeah,
I'm not good enough to quote the accident rates, but the problem is, if we could have autonomous vehicles where the accident rate is, say, a tenth of what it is with people, that's nowhere near good enough.
right.
Nowhere near good enough. That would not come close to being acceptable. And this is what they're having to struggle with: is
Mm,
these cars have to be almost
that's
perfect.
right.
So we have to go from 30,000 deaths a year in cars that we drive
Yeah,
to virtually nothing. It has to be like an aircraft.
that's right.
So the standards are so much higher
Yeah.
when you have the autonomous vehicle. But I think the initial opportunities will probably be more on the freight side.
Yeah, yeah. It seems to me, Warren, the human granted, the brain does very interesting things, especially under uncertainty. The human appears to be pretty bad in, kind of routine, repetitive activities because they make a lot of mistakes. And driving and the manufacturing floor where you have repeated component manufacturing, those types of things, machines appear to be a lot better than humans. And I always argued that humans are not really designed for those things. We get bored very quickly, and then we start to make mistakes. So, like you say, it's interesting that the requirement for autonomous vehicles to be widespread is sort of a zero fault criteria, where we are losing 30,000 people in accidents, mostly due
Yeah.
to
Look,
operator
machines
error, right?
don't send text messages while they're
Yeah.
driving. I mean, there's some really just obvious dumb stuff that people do that a machine won't,
Yeah.
that we get this instant win. But I'll tell you, all you need is that one thing where somebody's pointing a finger saying, look, the machine did this, this is terrible. And it gets really pushed back. So I think it's going to be a very slow rollout. We'll just have to see.
Yeah.
I don't know. It's going to take some time. The latest estimates I'm seeing is mid 2030s, but it'll be a slow rollout. I visited Phoenix not too long ago. Phoenix is popular as sort of an initial tryout city. Gosh, if you come from the Northeast and you go visit Phoenix, you're looking around going, okay, here's a 4-lane highway with no cars. So they're gonna peel off the easy spots. I think it's a long way until we see an autonomous vehicle in Boston in the winter time.
Yes. Yeah. Boston will be the last city.
It'll take a while, but I think the freight side, there's just so much economic pressure, and you have companies like Amazon that will push very, very hard. The Ubers of the world, I mean, they clearly got out in front of themselves, and with this idea of, oh my gosh, wouldn't it be great if we just get rid of these drivers? And that's still true, but I think they're now realizing that they lost a lot of money on that, and it's a long way away.
Yeah, it's counterintuitively though. So as you know, there are kind of 4 levels of autonomous vehicles. So level 4, they say there is no steering wheel. There are no controls. It's completely machine, and you just have a place that you just get in and it goes. And anything in between where you have steering wheels, you have controls, and you have a human being sitting behind that, it seems like it's more problematic, because one of the issues is, this, what is it called, disengagement, right? So the machine says, I found something, I don't understand it, I'm going to give you all the controls. And the human is not really prepared to take controls in such an instance, right? So the disengagement essentially leads to the accident that the machine is trying to avoid. One classic example of this is actually the Air France flight that crashed in the Atlantic coming from Latin America into Charles de Gaulle. And its altimeter, I believe, got frozen up. So the machine didn't know the altitude it was flying. It disengaged and gave all the controls back to the pilots. And, they're sitting there maybe drinking a glass of wine or something, and suddenly you have to take over the control of the aircraft. And humans are not really good at that, unexpected, situations like that. So what is your view? My view is that it is almost better to go to level 4, jumping, and not having that intermediate step, because intermediate step is actually quite problematic. The machine plus human.
Yeah, I think I agree. By the way, I think
together.
the highest level is level 5. The level 4, I think level 4 gets you to
Level 5.
a very high level of autonomy. I'm not an expert on this. Professor Kornhauser is. I think level 4 is virtually completely autonomous in a familiar area, whereas I think a level 5 is autonomous in an unfamiliar area. I mean, one of the things that these the people building autonomous vehicles are become impressed by with humans is that we can learn to drive in one city, go to another city, and we can still drive. We're able to transfer that capability, and vehicles
Yeah.
aren't like that. It's possible that we're going to have to go the route. China's experimenting. I think they have one city where they're effectively constructing the city for autonomous vehicles. So in other words, the roads and all the signs and whatnot have to be very clean. You can't have any of this old northeastern city type of thing we have in the US.
Yeah.
And highways are certainly much easier to build for autonomous vehicles. So if you have a long commute, then you can get in and reliably let the car take over as long as you're on the highway. But then you have to jump back in certain settings. The idea that I totally agree with you.
Yeah.
I think it's not going to be successful if we're going to be autonomous, but you have to sort of sit there with your hands around the wheel. That's just silliness.
Right.
So I think that we can do highway driving, and it's possible that the cities are going to have to say, look, we're going to have rules that there will be certain roads built for autonomous vehicles, and they're going to have to meet these standards and all that sort of thing. And we'll sort of start to build up an autonomous vehicle network.
Yeah, hopefully we learned something from this one. I really appreciate Warren spending the Sunday morning with me.
Thanks so much, Gil.
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.